Hello students, here I am going to discuss about digital subtractor circuit. It is a very easy topic but yet a very important topic to discuss. So let's start the video. In this video I am going to discuss about firstly about half subtractor. Second one is the full subtractor, and later on I will discuss you how to design a full subtractor using only half subtractor circuits. In this channel you will find regular topics or tutorials about different topics or subtopics on electronics. So if you are a newcomer to this channel, please subscribe the channel and press the bell icon just to ensure that every time a new video is posted in this channel, you will get it as soon as possible. Now let's come to the topic. For a half subtractor, there are two inputs and two outputs. The inputs are minuend and subtrahend, and the two outputs are difference and borrow out. So here is the truth table of a half subtractor. You can see that there are two inputs, minuend A, subtrahend B, difference D, and borrow out BR. Now the truth table looks like if A and B, both of them are 0, difference should be 0 and borrow out is also 0. If minuend is 0 but the subtrahend is 1, then difference is 1 and borrow out is also 1. Please note it carefully. Then for A or minuend 1, subtrahend 0, the difference will be 1 and there will be no borrow, and for both of the minuend and subtrahend 1, difference should be 0 and borrow out is also 0. So this is the truth table of a half subtractor. Now let's move on to how to derive the output expressions for the difference and the borrow out. Now for the difference D, we can write it as D equals to A bar B. Since the minuend is 0, that is A bar, subtrahend is B, that is A bar B, or there is another combination in which the difference is also 1, that is A B bar. And as you know that this is nothing but the output expression for an XOR gate, so we can write it as A exclusive B. Now let's move on to the borrow out expression or BR. It is 1 in only one case, so that is our A bar B. So these are the expressions for a half subtractor. These are the output expressions for a half subtractor. One is for difference and the other is for borrow out. Let's draw the circuit by using NAND gates only. Now as you all know that this is the XOR circuit by using NAND gates. So this is our difference output circuit, and just note it carefully that here from this point we actually are getting A bar B whole bar. This is the output of A bar B whole bar, and as you can see that our borrow out expression is A bar B. So just taking this output and using it in another NAND gate, we can get the expression for borrow out, that is only A bar B. So this is the entire circuit of a half subtractor by using NAND gates only. Now the second topic is, as usual, full subtractor. Now for a full subtractor there are three inputs, that is one is minuend, subtrahend, and the third one is borrow in from the previous stage of the subtractor. And there are two outputs, one is for difference out and the other is for borrow out for the next stage of the subtractor. So let's move to the truth table of the full subtractor circuit. Now the truth table looks like when AI 0, BI 0, borrow in 0, difference 0, borrow out 0. When AI 0, 0, 1, that means difference is 1, borrow out is 1. When 0, 1, 0, that is AI 0, BI 1, again difference 1, borrow out 1. 0, 1, 1, that is when 0 minus 1 becomes 1 and 1 minus 1 becomes 0, but there is a borrow, so borrow out will be 1. When 1, 0, 0, that means 1 minus 0, difference is 1, there will be no borrow. 1, 0, 1, 1 minus 0 means 1, 1 minus 1 becomes 0, and there is no borrow out. 1 1 0, so 1 minus 1 becomes 0 and borrow out 0. 1 1 1, that means 1 minus 1 is 0, 0 minus 1 becomes difference 1 and borrow out 1. So this is the entire truth table for a full subtractor circuit. So move on to the output expression for both the difference and the borrow out. So difference di equals to ai bar bi bar, ai bar bi bar and borrow in. That is the first combination. Then the second one is ai bar bi borrow in bar. The third one is ai bi bar borrow in bar, and the last one is ai bi borrow in, ai bi borrow in. So now taking common of borrow in from the first and the last term, we get ai exclusive bi bar borrow in. That is, it is actually the output expression for a XNOR gate, and taking borrow in bar common from the second and the third term, we get borrow in bar common, we get ai exclusive bi, and this is the borrow in bar. So at the last term we can write this is actually ai exclusive bi exclusive borrow in. So this is the final output expression for the difference of a full subtractor circuit, that is ai exclusive bi exclusive borrow in, exclusive borrow in. I think it is clear to you all. So let's move on to the borrow out expression. The borrow out expression can be written as BR0 equals to, or borrow out equals to. Here also there are 4 combinations in which the borrow out expression is high. So writing one by one, we can write AI bar, BI bar, borrow in. This is our first combination. Then move on to the second one, that is AI bar, BI, borrow in bar. Now the third one is AI bar, BI, borrow in, and the last one is number 4, that is AI, BI, borrow in. So this is the output expression for the borrow out in a full subtractor circuit. Now by simplifying the output expression for borrow out, I get AI bar BI or AI exclusive BI bar and borrow in. Now as I am going to draw the circuit of a full subtractor by using NAND gates, so I am going to apply De Morgan's theorem here, and I get AI bar BI bar and AI exclusive BI bar borrow in bar, and then the entire bar. So now the last step remains, that is to draw the circuit of a full subtractor by using NAND gates only. So this is the entire circuit of a full subtractor by using NAND gates. Look at this circuit, there are only 9 gates used for the full subtractor circuit. So you only require 9 NAND gates to construct a full subtractor circuit. In this part of the video, I am going to show you how to construct a full subtractor circuit by using only half subtractor circuits. I am writing the output expressions for the full subtractor, that is DIFS, that is the full subtractor difference output, and it is nothing but DI half subtractor exclusive or borrow in, and the borrow out full subtractor can be written as borrow out half subtractor 1 or borrow out half subtractor 2. So we are using two half subtractor circuits. One is HS1 or half subtractor 1 and the other is HS2 or half subtractor 2. So let's move on to the circuit. So the circuit of a full subtractor using only half subtractor is like this. Here I have used half subtractor 1 and half subtractor 2, that is the two blocks of half subtractor. AI and BI are the inputs for the half subtractor 1. This is the difference out for the half subtractor 1, that is, as you know, it is nothing but AI exclusive BI. And for the half subtractor 2, these two are inputs for the circuit, that is the difference of half subtractor 1 and the borrow in. So the output or the difference output of the half full subtractor can be taken out from the output of the half subtractor 2, and by taking an OR gate with the inputs of borrow out of half subtractor 1 and borrow out for the half subtractor 2, we can get the borrow out expression for a full subtractor. So this is the entire topic of subtractor. To know about digital adder circuit, you can watch these videos right here. Till then, goodbye. See you later.